Okay, so now again, after the destructor outputs where we start the rest of the outputs. So the first block here, that was strictly with static binding, right? That's where we were just using the objects directly to print everything out. But then we down here started processing things in a polymorphic way. And we had, again, the two sets of function calls, one to the pointer function, one to the reference function. But we're just getting the expected output here. So we print out the SE object, the CE object, and the BPCE object. And so this is all coming right through repeatedly calling that virtual via pointer function. And then the second block here is the same thing again, except now we're calling the reference function, the virtual via reference function, where it's a reference parameter instead of a pointer parameter. So polymorphism works off both pointers and references, right? And then, but we're getting the same output here again. So again, it gives us an idea of, at least as a starting point anyways, how we can think about generalizing this whole process of dealing with the objects in a polymorphic way. But again, in this case, we were only calling the common functions like earnings and toString, which is why everything was kind of very straightforward and intuitive. But the next example we'll see, there's going to be a little bit more going on if we want to be able to do things like, for example, iterate through a vector of type employee star, but do a little bit of a different thing, for example, with the BPCE object compared to the other objects. We can still do that. There's just a little bit more that we'll do there to achieve that through what's called downcasting. Okay. Okay, so now we'll look at, again, same 4 classes, just a little bit of a different application program this time, and a little bit more going on. So here, we're still going to be printing things out, but we're going to want to do a little bit of a different thing, a little bit more really with the BPCE object in particular. So we're going to do things like call the set base salary function, change that, and then print out again. So in the beginning here, we still are working with the vector of type employee star, and the name we gave it is employees. In this case, we use some dynamic memory allocation to actually build the vector. So each index here in the initialization list, we're using the keyword new. And so first index is a SE object, second one is a CE object, and then the third one is a BPCE object. And then we want to be able to, just like before, right, we want to polymorphically process, right, each element in this vector of type employee star. And now things like the earnings and toString, right, that's same idea as before, because those are the common functions. Let me stop this for a minute so I can move that window. Yeah, so calling things like the toString, that's really the same as before, because that's a common function. So again, we're using a similar type range-based for loop here, type employee star for the pointer. And then here we're calling toString. That's the same really almost as the last project. But now we're going to be doing a little bit more to handle things like if we want to call one of those functions like the set base salary, which is specific to a BPCE object, right, but does not exist in the other class. And so what we're going to do here to start with is we're going to do what's called downcasting, or we're going to try to really. And so the statement here, what we're doing with this, where we're trying to do a downcast, is we're defining a new pointer, but you'll notice this time the pointer is not of the parent type, but rather the pointer is of type BPCE, right, base plus commission employee. And then the name that we gave the pointer was, meaning the name here was derived PTR, or perhaps child PTR, but we're calling it derived PTR. But then if you look at the right-hand side of the assignment statement, what we're doing is a casting operation. So, and we're doing what's called a dynamic cast, because the idea is kind of related to the issue of dynamic binding. We need to actually look at the object that the employee pointer is currently pointing at, and we actually want to look at the type of that. Because with this statement here, what we're saying is dynamic cast, and then in the angular brackets, we have the type, right, BPCE star, the same type as the pointer derived PTR. And then the thing that we're trying to cast is the employee pointer, meaning the pointer, because this is, right, we're still within this range-based for loop here. So the idea is that we know that on each loop iteration, employee pointer is pointing at the current object from the employee's vector, right, whichever one you're currently working with. And that object may be one of three types, right? Salary employee, commission employee, or base plus commission employee. Now, the whole idea is that we want to actually take into account what type of object are we currently pointing at, because that's going to have an impact on what happens with this downcasting statement. In other words, it's going to work differently, right, with a BPCE versus a CE or SE object. Because what it's going to do, what it's really trying to do, is it's looking at the thing that employee pointer is pointing at, right, that object, and it's going to try to do what's called a downcast. And we call it downcast because in general, you know, when you are working off of like a parent class pointer, and then you're trying to cast it to the type of one of the child classes, we call that a downcast, right? Because you're casting it from a higher level type in the hierarchy to a lower level type, right? So because employee pointer, right, the type of that is employee star, right, which is the top level. And then here, this statement is attempting to cast that from type employee star down to type BPCE star, right, or base plus commission employee star. So we call that a downcast, right, going from a top level down to a lower level in the inheritance hierarchy. But see, the idea is that whether that's going to actually happen depends on what employee pointer is actually currently pointing at, as far as what's going to really happen with this statement here. So if employee PTR is currently pointing at a BPCE object, then the downcast is going to be what you might call successful, right? It's going to actually go through. But if the employee pointer is currently pointing at a SE object or a CE object, what's going to actually happen, and we'll see how this connects up with what comes next. But if employee pointer is pointing at an SE object or a CE object, what's going to actually happen is you're going to end up storing null PTR in the derived PTR pointer. Whereas if the pointer is pointing at an actual BPCE object, then the pointer derived PTR is going to be pointing at that object. So we have a clear way of distinguishing with the next part here, a BPCE object from the other two types, meaning from a commission employee or a salary employee. Because the stuff that we're doing in this if statement is specific to a, a BPCE object, a base plus commission employee object. But the things that we're trying to do in the if statement should not be done if the object that we're currently processing is either a salary employee or a commission employee object, because they don't, right, they don't have things like a set base salary or a get base salary function. So one of two things is going to happen, right, with this, and that's why we say it's really an attempt at downcasting. But one of two things is going to happen, right? If employee pointer is currently pointing at a base plus commission employee object, then the address of that base plus commission employee object is going to be stored in derived PTR. If employee pointer is pointing at a commission employee object or a salary employee object, then the downcast is not going to be successful, right? Because that's not, something that we can do, right? If this is the address of a a commission employee object or a salary employee object, right? Well, there's no way to convert that to base plus commission employee. But on the other hand, if the pointer itself is pointing at an actual base plus commission employee object, well, we can cast that to type base plus commission employee star. It's just we can't cast a commission employee object or an employee object of that type. So what's going to happen then is if this pointer is pointing at a base plus commission employee object, then the downcast is going to be successful and derived PTR is going to point at that base plus commission employee object. But if employee pointer is pointing currently at a salary employee object or a commission employee object, then the right-hand side here is going to evaluate to null PTR, because the downcast was not successful, and then null PTR will be stored in the derived PTR pointer. And then the idea is that's something that we can check for, because those are the only two possibilities in terms of what's going to happen with derived PTR. Either it's going to end up storing the address of a base plus commission employee object from that vector that we're looping over, or it's going to be storing address 0, meaning null pointer. So we can check for that to distinguish when we need to do the logic here versus when we don't need to do it. So in particular, when we're looping through this vector of 3 elements, on the first loop iteration in the range-based for loop here, right, employee pointer is going to be pointing at this salary employee object that was created dynamically, and we'll call toString. But then when we attempt to do the downcast, since the object is a salary employee object, right, this is not going to be possible, right? We can't cast it to that type. So we're going to get null pointer, and that's going to end up here. And then when we get to the check, this is going to be false, right? Because this says if derived pointer is not equal to null pointer, then do the stuff inside the if brackets. But we're going to skip that since it is null pointer. So in that case, the only thing that we're going to do is toString and then earnings. And similar idea on the second loop iteration, but that time we have a commission employee object that we're pointing at. Same idea though, we're not going to be able to cast that to type BPCE star, so we're going to end up with null pointer in the pointer. And so we're not going to do the statements here. So we're only going to do toString and earnings. But on the third loop iteration, now we actually are dealing with, right? We actually are dealing with a base plus commission employee object. So, and again, with dynamic cast, it's taking into account what the pointer is pointing at, right? So it's not just looking at the type of the pointer, it's looking at the type of the object the pointer is pointing at. And that determines whether we can really do the downcast or not. So in this case, with the third loop iteration, since it is pointing at this BPCE object, we can cast that to this type, right, to the base plus commission employee star type. And so the address, right, the address of this object on the third loop iteration is now going to be stored in derived PTR. So when we get down to here on the third loop iteration, it's going to be true, right? It's not equal to null pointer. And then we're going to do everything we're going to do all the statements that are there, meaning call get base salary, print it out, and then we actually change the salary, right? We do a little bit of an increase, and then we print it out again. But that block, right, only happens when we're processing a base plus commission employee object from that vector, but it does not run when we're processing a salary employee or commission employee object. So again, it's a way of handling those cases where, sometimes we want to we still want to process everything together polymorphically, right? Because this is all within one for loop that loops over that one vector. But at the same time, we're able to handle those functions that don't exist right at each level in the inheritance hierarchy. And so the technique here was what we again call downcasting. So this part here is what we call a downcast, or an attempt at downcasting. So that's the gist of what we're wanting to accomplish here. And again, downcasting is just very convenient because it's going to handle this exact type of scenario for us. So again, we use dynamic cast here, so that way it's going to dynamically look at the type of the object the pointer is pointing at, rather than just looking at the type of the pointer itself, which is always employee star. Look at the actual object. That determines whether the downcast is successful. And then again, we saw that if it was successful, then derived pointer would store the address of that base plus commission employee object, which would allow you to do the extra logic here. But if the employee pointer was pointing currently at a salary employee or commission employee object, we said that the downcast would ultimately not happen, but you would instead end up storing null PTR in the pointer, in which case you would skip and not do the logic in this if statement. Okay, question about downcast. So downcasting only works. Yeah. Because, well, here in particular, because the pointer itself, I mean, the pointer itself is employee star, right? So because that's what we define the vector, but we know that in general, we could have really any of the three types of child classes, those types of objects could show up in the vector. But in particular, we're saying what we want to cast it to is the type base plus commission employee star. So, but if the object itself is a salary employee, then that's not going to go through, right? Or even if it's a commission employee, it's not going to go through. The only way it's going to go through is if the pointer itself is already pointing at a base plus commission employee object. Because see, I mean, the whole idea is that the type of the pointer employee PTR, we know that's never going to change, right? That's always employee star. But the type of this pointer, right? The type of this pointer is directly of a child class type, right? Because the type of derived PTR was defined as BPCE star. And then one of the things that we said very early on in chapter 12, right, is that, you know, we know that you can't take a child class pointer, right, and try to point it at a higher level object in the inheritance hierarchy, right? We know that, for example, you can't take a base class, a BPCE pointer and point it at, you know, a CE object, or or if the class was not abstract, right, then you also could not point it at an employee object. Of course, it's abstract, so we can't create employee objects in the first place, but that's the idea. So because, you know, for example, if we try to just do something like BPCE star derived pointer equals, you know, a commission employee object, that would actually be an error. Now here, it isn't an error because there's different behavior depending upon what the pointer's pointing at. But the whole idea, going back to the fundamentals of polymorphism, it's never going to be the case, right? The derived pointer is going to be storing the address of either salary employee, which is not even apparent at all, right, at BPCE, but it's also not going to be storing the address of commission employee, which is its parent. But we know that in general, right, with polymorphism, you are not, you know, we cannot aim a child class pointer, right, at a parent class object or grandparent or however many levels we have, because of the is a relationship, right? The is a relationship only goes in one direction. So, you know, if we try to just do something like that, like just kind of generically say base plus commission employee star derived pointer, you know, equals the value from the vector, well, that would be an error in general, right? Because we can't do that. But the dynamic cast makes it okay, because now we kind of situationally deal with this, right? Depending upon what the pointer's pointing at. So the idea is that if it's, if it's a CE object or a SE object, we're going to detect that, right? We're going to detect that, ultimately we can't do that, right? But if it is a BPCE object, then this whole statement is going to go through, meaning that this whole big thing that says dynamic cast, really in the end, right, it's just going to return the address of the BPCE object, which is then stored in the BPCE pointer. Whereas if it's a CE object or a SE object, we're going to ultimately end up with null pointer, because that's what happened if the cast cannot actually be done, is we just return null pointer. So in the end, right, that would just mean the statement would in effect become BPCE star derived pointer equals null PTR. So that's why this whole thing is okay, because we're not going to actually allow a statement like trying to aim this pointer at a CE object or SE object. That's never going to actually happen, right? The dynamic cast is going to make sure that that never actually is allowed to happen. So we never run into a compiler error, right, as a result of this, because the dynamic cast is going to handle it, is going to be able to handle it in the correct way. So that's why we said it's also really an attempt at downcasting. But since we know it's one of those two things, right, either derived pointer storing the address of the base plus commission employee object, or null PTR, now we have a clear way of distinguishing when we want to do the logic or when we want to skip the logic. And that's exactly what we did here in this if statement. So if it's not null, everything goes through. If it is null, then just don't do it. Then we don't run into any problems, right? Because then we're never gonna, because of course we, we can't say stuff like null pointer arrow get base salary, but as long as we're checking that, then we know that that kind of thing is never going to happen. So these two things together is gonna allow us to handle those, that extra logic that we want to do for a base plus commission employee object, right? That we're not going to do otherwise. So again, the downcasting was very convenient here because it just gave us kind of a generalized way of dealing with that extra logic. And it'd also be you could do a similar kind of thing if you wanted to do something, special for only a salary employee object, right? You could, in a similar manner, set up a separate pointer of type SE star, try to do the downcast, and then do only those calls with that object. So it'd be a similar thing for some of the other classes, whether it's CE or SE. But in this case, we were saying that the only time we wanted to do extra logic was with a base plus commission employee object, which is what we're doing here. Mm-hmm. And then again, that's the major new thing here. And then the other thing that didn't come up in the other one but comes up here is because we use dynamic memory allocation, we also wanted to clean everything up. So we loop through the vector again and we just delete everything. And then a little bit more that's done here also is this part here, which prints out, this is just going to print out the word class and then the name of the class, like deleting object of class salary employee or deleting object of class base plus commission employee. So this whole thing here is just going to ultimately print out the name, the word class, and then the name of the class, right? The type ID and the name. And then at the bottom here, we just delete, right, the object, right, the one that we previously allocated with new up here. So we're just cleaning up the heap, right, before the end of the program. But that's the idea. Again, why downcasting is so useful, because now we can handle really anything that comes up. Not only handle earnings in toString, but also handle those functions that don't exist, right, at every level, right, at every level in the inheritance hierarchy. Mm-hmm. So with this one, again, a little bit more than the last version, because now, right, there's going to be there's going to be additional outputs for the last object, the BPCE object, because of the extra logic, right, that we have here. Okay. And so that's our output here. So in this case, dynamically create the objects, put the objects in the vector, loop through the vector. For the SE and commission employee object, we just call earnings in toString. For the BPCE object, we did that extra logic in the block, right, where we actually increased their salary a little bit. And then we print out the old salary and the new salary with the increase that we applied. And then again, we have that second for loop that was deleting all of the dynamically allocated objects. And we also set it up to where it was printing out the name of the class as well. So deleting object of class SE or CE or BPCE. But again, that just gives us an idea also of downcasting, right, and how that works. And again, it was really convenient here for handling those functions that don't exist, right, at each level in the inheritance hierarchy. Okay, so that really wraps up the major topics here with polymorphism. So we'll start to look now at things like templates, and then we'll look a little bit at container classes. So you're very familiar, especially with things like the vector class, but we'll look at some of the other classes in the STL library like DQs and list and so forth. And then we'll also look at the issue of templates and how we can make either a class or a function templated, right? So again, vector is an example of that because vector is what we call a templated class. So that's why whenever you declare a vector object, in addition to specifying things like the name of the vector and maybe the size or maybe an initialization list, you also have those angular brackets where you put a type, right? Like vector int inside the brackets and then V for the name of the vector, or vector char in the brackets and then VC or something like that for the name of the vector. So the reason why the syntax is like that, right, is because it's a templated class. And so far, the classes that we've been looking at have not been templated, which is why we haven't been using things like those angular brackets when we create the object. But now we can also start to think about that type of scenario. So, and again, we'll see that it's something that's very powerful, right? We can apply the concept of a template to both an entire class as well as to functions. So sometimes, for example, we might want to take a standalone function, maybe say in the application program, and make it a templated function. So we can apply it to a class. We can also apply it to functions. And it's going to give us flexibility in terms of type. So just in the same sense, right, that when you create a vector object, right, you can create a vector of integers, you can create a vector of chord object, you can create a vector of characters, you can create a vector of string objects. In the same way that we can do that with something built in, like the vector class, right, you can also set up your own classes to work in that way as well, to where, you know, not only can you create an object of a certain type, but we also have some control over the types of the object as well. So we'll see, you know, how you can set those things up with your classes and functions. And then as we go through some of the built-in container classes, we'll see that they also take advantage of this concept of templating as well. But any questions here before we go to break?